Okay, I want to briefly introduce you to secretion and the exocrine mechanisms in the GI tract. This is the beginning of the second sweep through the GI system, which will focus on the secretions and their functions. So the functions of the GI secretions are twofold. Firstly, the digestive function that aids in breaking down the macromolecules into things you can absorb, and then there's a protective function that allows the GI tract to perform its function without excessive damage to it. Examples of these include providing the enzymatic machinery for breakdown of nutrients for absorption. It starts in the mouth with the salivary amylase to break down carbohydrates. It continues in the stomach with the release of acid and pepsinogen, and the pancreas and the bile acids also release stuff into the GI tract that break down nutrients for absorption. It also provides the necessary cofactors for absorption. One good example of this is vitamin B12, which would be broken down quite easily by the gastrointestinal tract into an unusable substance, but it binds to a protein R or R protein in the mouth, and then switches to intrinsic factor lower in the gut, and this enables vitamin B12 to pass through the GI tract intact until it is absorbed. The salivary mucus and the other mucus that's produced in the GI tract lubricates the food bolus and allows ease of passage and prevents any sort of friction causing damage. The salivary secretions, or the secretions up and down the GI tract, provide proper ionic and osmotic milieux for enzyme action, i.e. regulating the pH so that the enzymes are at their optimum pH levels, and this also couples with absorption of nutrients to aid absorption to maintain your influx of food and fuel. The mucosal barriers, mucosal layers aid in repair, replacement, and barrier functions of the intestinal epithelium to prevent damage from quite corrosive secretions. And it also has an important role in contributing to body fluid homeostasis. And also the secretions have immunological functions through secretory immunoglobulins, antibodies, and inflammatory mediators that serve as protective functions for the GI tract. The general composition of digestive secretions are shown here. Water is the largest component by volume. And then you have electrolytes, salt, sodium, potassium, bicarbonate, and chloride. And then there are specific organic constituents that are important for digestive functions, like digestive enzymes and mucus and the bile salts that are contained within the secretions that allow it to perform its functions. What creates or what secretes secretions from the GI tract are termed secretagogues, and these are substances that will stimulate a secretory cell to secrete its contents. And you have different types of these. You have the neurocrine secretagogue, and these are neurotransmitters that are released from neurons that innervate the secretory cells, like acetylcholine from the vagus nerve, and then these neurotransmitters will affect a certain secretory cell, and then the secretion will come out of the gland, and this is neurocrine. Endocrine secretagogues, these are hormones that are released from distant endocrine cells and then transported through the blood to affect the cells and cause a secretion. And gastrin from G cells activate acid secretion from parietal cells. And this happens directly on these parietal cells to release acid, and that's an example of endocrine, because they're produced from a distant place, pass through the blood, and affect the secretory cells. And then you have paracrine secretagogues, which are released into the neighboring environment of the cells and pass through diffusion, affecting them and causing secretions. And a great example of this is histamine, which is a paracrine agonist for the parietal cells in the stomach, to stimulates the release of hydrochloric acid. The mechanism of gland secretion is shown here. You have these glands that have a lumen, and this lumen is then surrounded by these exocrine secretory glands, which secrete their products into the lumen of the gland, and then is passed out through the duct into the GI tract. And the products for the secretions all come from the blood supply, and everything you need to create the saliva or the mucus comes from the blood, and that enables this sort of secretion blood flow coupling to happen. Whereas if you need more secretions to come out of a particular gland, the blood supply will generally be increased to that area, supplying more fluid and electrolytes, so that the cells can create more secretions upon demand. And obviously in the reverse then, if blood supply is reduced, then the secretions are obviously going to be reduced as a result. And this gives your system, your body, ways of regulating the release of secretion products from these glands by altering the blood supply. And so in later videos we will talk about local secretory events, and these will include the salivary secretion, gastric secretion, pancreatic secretion, bile secretions, and then lower intestinal secretions in the ileum and colon.